Good afternoon. On behalf of the I-BiDaaS Consortium, I would like to welcome you to the Big Data Pilot Demo Day number 7, I-BiDaaS Application to the Manufacturing Sector. My name is Dušan Jakovetić. I'm Project Manager at Forth. Forth is coordinating the I-BiDaaS project. So we are very happy that you are all here. First, I would like to say a few things about today's webinar's speakers. With us is Dr. Dušan Jakovetić. Dušan is an assistant professor at the University of Novi Sad in Serbia, and he's also the I-BiDaaS Scientific and Technical Manager. Today also with us is Giuseppe Danilo Spennacchio. He's a flexible and adaptive system specialist at Factory Innovation Department, CRF in Italy. So let's go briefly through today's agenda. First of all, we will start with an introduction to the Big Data Pilot Demo Days. It is a joint effort between BigDataStack, I-BiDaaS, Track and Know, and Policy Cloud projects. Then Dušan will present an overview of the I-BiDaaS project. Danilo will present the requirements set by CRF. Dušan will follow with the scientific and technical view of the I-BiDaaS architecture and how it addresses the requirements set by CRF. Then Danilo will demonstrate the I-BiDaaS solution in a step-by-step fashion and its application to the manufacturing sector. Then Leonardo will say a few things about the next webinar. And finally, we will open the floor for questions and answers. A few details here. You are all muted. However, you can post your questions in the Q&A panel. There is also the option where you can raise the hand. So the speakers will be more than happy to reply to all of your questions at the end of this webinar. So before we start, we would like to learn a few things about the audience that we have today with us. So Diego, may I kindly ask you to launch the poll? So 4 questions, easy ones. Let's give 1 to 2 minutes maximum for this. We would like to learn a little bit about your background. If the type of the stakeholder you belong. I see that people are answering. The percentages are increasing. Let's give some time here. I can see that we have a lot of people from research and academia. We have a lot of big data technology providers. We have people from the manufacturing sector. Half the way through. So I still see that 71% is from research and academia, 24% from big data technology provider. So, second question, are you working with big data? 68% said yes, some of them no. Are you interested in big data technologies to optimize your customer experience? 74% are interested. And the final question, what is the main barrier of risk preventing you from implementing big data analytical solution in your organization? I can see that 50% replied lack of expertise. So yeah, I-BiDaaS can help on that since it's a self-service solution for both IT and non-IT users. Okay. I think, Diego, we can now close the poll. Thank you all. So before we start, I would like to go over a quick introduction to the Big Data Pilot Demo Days series of webinars. So as you are all aware, Big Data Value PPP Summit 2020 went virtual due to the COVID-19 outbreak. This pushed us for different ways of thinking and different ways of collaboration. So why Big Data Pilot Demo Days? The new data-driven industrial revolution highlights the need for big data technologies to unlock the potential in various application domains. I-BiDaaS BigDataStack, Track and Know, and Policy Cloud all these projects deliver innovative technologies to address the needs of data operations applications. To fully exploit the sustainability of the developed technologies, the project onboard pilots to show their applicability in a wide variety of sectors. I-BiDaaS BigDataStack and Track and Know are in their third and final year, and they are ready to demonstrate the developed and implemented technologies to interested end users from the industry and technology providers. And the Policy Cloud, recently started, will highlight the adoption of technologies developed by the more mature Big Data Value PPP project, BigDataStack, to showcase its application to the policy-making sector. So here you can see the full list of the project. BigDataStack, holistic stack for big data applications and operations. I-BiDaaS, industrial-driven big data as a self-service solution. Track and Know, big data for mobility, tracking, knowledge extraction in urban areas. Policy Cloud, cloud for data-driven policy management. So all these projects join their forces to showcase its application of innovative technologies in a wide variety of domains like telecommunication, finance, manufacturing, insurance, shipping, and so on and so forth. Here you can see an overview of the series of webinars we have designed. There are 9 in total. Today we are on the 7th. All these webinars are available in our YouTube channels, in our websites, under the Big Data Value website. So if you missed a webinar and you are interested, you can visit it at any time. 2 more left for next week. Don't miss them. They're very interesting. So without any further delay, I would like to pass the token to Dušan to start with a presentation of the I-BiDaaS overview. Dušan, the floor is yours.
Thank you, Despina. My name is Dušan Jakovetić. I'm from University of Novi Sad, Serbia, and I'm going to give a brief introduction to I-BiDaaS project. So first, the identity card of the project. We are a consortium of 13 partners with a total budget of slightly less than 5 million. We started in January 2018, which means that we are at about half a year till the project ends. The full title of the project is Industrial Driven Big Data as a Self-Service Solution. This is a research and innovation type project, which means that we do both research and also we are making efforts to drive this research somewhere closer to the market. Here you can see various links to various media where you can contact us. Our consortium is a well-balanced 13 partners consortium with large and small industries, research institutes and universities. In particular, we have Ford from Greece, which is the project coordinator, Barcelona Supercomputing Center, IBM Israel, CRF, which is a research center of Fiat, Software AG, Caixa Bank, University of Manchester, Pont School, Atos, Spain, Aegis, which is an SME from UK, ITML, another SME from Greece, University of Novi Sad, and Telefonica Research from Spain. Motivation of the I-BiDaaS project, as with several other BDV PPP projects, is related to the European data economy. And there are several challenges or barriers that we need to work on in order for us to be able to, through research and innovation, to help in improving the data economy. For I-BiDaaS, I would like to mention the two most relevant. One of them is the lack of talent. By this, we mean that industrial companies often have big data available, but in order to fully harness the value from the data, they need to interact with the big data technologies, which are often very complex and diverse. And it could be either very costly to hire experts, or there may be a lack of experts in the market. And the other challenge relevant for I-BiDaaS is the data silos that exist both within a single company, within a single sector, or across multiple sectors. And if properly broken, then we can make potential improvements in the company's operations. Related with these challenges, you can see here several important dimensions of the vision of the I-BiDaaS project. I'm going to focus on 3 of them. So in relation to the lack of talent challenge, I-BiDaaS provides a big data as a self-service solution that helps employees of industrial companies to more directly interact with big data technologies. Through several activities and technologies within the project, I-BiDaaS is helping and showing how we can break data silos. And finally, I-BiDaaS offers a complete and safe environment for methodological big data experimentation. In particular, I-BiDaaS focuses on 3 sectors: manufacturing, finance, and telecom. And today, the main focus for us is manufacturing sector. With these elements of the vision in mind, I'm going now to basically read this slide to make the project statement. So I-BiDaaS aims to empower users to easily utilize and interact with big data technologies. So this is the self-service part, by designing, building, and demonstrating a unified framework that significantly increases the speed of data analysis while coping with the rate of data asset growth, and facilitates cross-domain data flow. So this corresponds to breaking the silos towards a thriving data-driven EU economy. I-BiDaaS will be tangibly validated by the 3 real-world industry-led experiments, and here we mean manufacturing, finance, and telecom. A little bit more about the experimentation of I-BiDaaS. As I mentioned, we have the 3 key sectors that we target. Our today's focus is on manufacturing, while we have had in this webinar series also the sessions for the telecom and banking sectors, and and the links to these events are available. And the final slide for this slot is meant to say that besides the 3 targeted sectors, I-BiDaaS tools and technologies can also be applied in other sectors as well, as for example, energy or health. Thank you. So now I would like to pass the token to Danilo, who is going to describe the requirements in the context of I-BiDaaS for the manufacturing sector. Thank you.
Thank you, Dušan. My name is Giuseppe Danilo Spennacchio, and I work as flexible and adaptive system specialist at the CRF in Factory Innovation Department. Now I share with you the presentation with the CRF requirements. As I said, I work at CRF.
Danilo,
yes?
We cannot see your slides. Maybe you need to share the...
Now?
Yes, we can see
okay.
the slides.
Thank you. Thank you, Despina. Sorry. I work at CRF. CRF is the acronym of Centro Ricerche Fiat. Is one of the main private research centers in Italy. Our headquarters is in Urbassano, and we have other 5 sites, 2 in the north and 3 in south of Italy. CRF was founded in 1978, and our mission lies in 3 main goals. We develop innovative power units, material vehicle systems, methods, and processes to improve the competitiveness of Fiat Chrysler automobiles product. We participate in European and national collaborative projects, taking part in pre-competitive research projects and promoting the development of a network of contacts and partnership on an international scale, and support FCA in enhancing the value of its intangible capital. In CRF, there are over 900 employees. We have 2,573 patents and 592 inventions. Why do we need I-BiDaaS? We live in automation era. So we have a massive amount of data that are stored in the industrial plants. And so the value of information is higher. For this reason, we need data analysts and technologists to analyze and visualize data in order to improve the quality of the process and to reach customer satisfaction. Do you see my screen?
Yes, Danilo, we can see the screen. Maybe you can put the slides in the full screen, press the button to change the slides. Yes. Maybe you should stop sharing and do that again from the beginning because something is not. Okay, we can see now your full screen. The slides. Now? Yes, perfect. Okay.
Okay, thank you. So, manufacturing sector need to create a network with specialists with different competencies to improve digital services. For all these reasons, we are in the I-BiDaaS project, industrial-driven big data as a self-service solution. Data retrieved in the plants are strictly confidential, so it is very important as a requirement data privacy. And for this, we anonymized all data that we received from the plants before sharing them with the partner in project and external. Production lines provided with computers store massive amounts of structured and unstructured data. And another requirement is the dataset generation. Analysts identified irrelevant parts of the data and cleaned them. Other 3 important aspects that we take into account if we consider manufacturing sector are the lack of time to extract and analyze data because rhythm of production are very fast. Also, there are fast internal changes due to rescheduling production quantities and component variations. And for security procedures, we have the slowdown of data sharing. For these three aspects and other, we need data analysis and advanced visualization tools provided by experts to empower data providers' decision. The objective for CRF is the quality improvement and predictive maintenance within I-BiDaaS project. So we are exploiting the I-BiDaaS platform to develop a methodology for quality and process improvement and for predictive maintenance. In the Plan, Do, Check, Act diagram, I summarized the 4 steps. We identify 2 use cases, define the steps we need to take, and enter in the I-BiDaaS project. In the do phase, we define the identified use cases, share data with the consortium, and carry out the plan in the I-BiDaaS platform. In check phase, we analyze the results that we received and verify that we have improved the plan. So in the act phase, we can implement the plan by developing a methodology for our supplier and update the standards operating procedures. Other 2 important aspects are breaking data silos and the use of I-BiDaaS platform as a service. About the first aspect, this project is very important because we are integrating data from different sources and levels. We are involving external and internal departments, and we are between the plans and consortium with our analysis that we made in CRF. About the second point, as I said at the beginning, I-BiDaaS as a self-service solution and I-BiDaaS solution is empowering our usage of massive quantities of data to discover all information that are inside in the hidden data, and include new competencies in data analysis. Another important thing that I say here, that we are in the world-class manufacturing research and innovation department. So we follow WCM strategies. WCM is a structured, rigorous, and integrated production methodology adopted at FCA plants worldwide, which involves the entire organization from safety, environment, maintenance, logistics, and quality. Project developed under WCM methodology targets the elimination of all form of waste and loss, with the ultimate objective of achieving 0 accidents, 0 waste, 0 breakdowns, and 0 inventory. Another important aspect in the competitiveness and innovation is to analyze data in real time or near real time to solve a problem and to update internal procedures. With all these aspects, we can reduce manufacturing costs due to the quality and maintenance issues, and reduce environmental impact by reducing material and energy consumption. Dušan is going to give the description of the big data architecture within the process. The floor is yours, Dušan.
Thank you, Danilo. I'm going to present the architecture of the I-BiDaaS from the front end, sort of what it offers to the users. Also from the back end, explaining what technologies we are developing in the back end to make these functionalities available to users. And then I'm going to describe how the I-BiDaaS architecture can be specialized to solve the use cases provided by CRF. So what you see here at the slide is a standard end-to-end big data pipeline. We have some users, they have some data, they analyze their data and see the results. I'm going to highlight some features that we believe distinguish I-BiDaaS from alternative end-to-end models. So on the side of users, we have a flexible solution that has 3 modes of operations: the expert, self-service, and co-develop. The expert mode is meant for expert big data developers that can upload their own code on the platform. The self-service mode is meant for the users that have some data analysis and statistics knowledge, so they can select a predefined algorithm available in I-BiDaaS for the domain problem. And finally, we have the co-develop mode, which is meant for industrial in-house employees who will develop their application with the help of I-BiDaaS team. On the side of data, we, for example, incorporate the realistic synthetic data fabrication technology provided by IBM that allows to experiment with big data in scenarios when not sufficient real data is available, or when due to privacy concerns real data cannot be shared. On the side of analytics, we incorporate both stream and batch analytics, and on the side of results, we can visualize the results and share models. From the back end, this is a complete picture for the I-BiDaaS solution. I'm going to break it down according to the work packages of the project, so that I briefly describe what we have in there, not so much how everything works. So on the side of data, user interface, and visualization, we have the IBM TDF technology, which allows for realistic synthetic data fabrication. We have the software AG's universal messaging, which is a message broker that makes the data available to other components in the platform. And we have the AG's AVT, which is an advanced visualization toolkit. On the side of batch analytics, we have the Barcelona Supercomputing Center's COMPS programming model, Hecuba, which is a data management tool, QBeast, which is a data indexing tool, and finally, University of Novi Sad and other partners of the project are developing machine learning implementations of algorithms in the COMPS programming model. On the side of streaming analytics, we have the software AG's APAMA complex event processing engine and the Ford's GPU accelerated analytics. And finally, on the resource management and integration side, we have the Atos resource management tool and the ITML integration services. Now, let me go briefly over the key features and the technical innovations of the project. So as mentioned before, we incorporate in end-to-end big data solutions data fabrication capabilities. Then we offer the solution flexibility with the 3 modes of operation: expert, self-service, and co-develop. We allow for an easy-to-code programming paradigm thanks to the COMPS programming model. And through various research and innovation activities of the project, we can offer to developers a high code reusability. On the side of streaming analytics, we provide a synergy of complex event processing and GPU accelerated analytics. And the further innovations are feedback from analytics to data fabrication and to problem modeling. All of these innovations have been demonstrated on use cases across 3 different data providers in 3 different sectors. And for today, our focus is on the manufacturing. So what I'm going to do next is I'm going to describe how the I-BiDaaS solution is specialized to the use cases provided by CRF. I'm going first to present the context of the use case, then the challenges that the use case involves from the data analytics and the big data technologies perspective, then briefly present the I-BiDaaS solution, and then show how the architecture specializes to the respective use case. So the first use case is the production process of aluminum die casting, where the context is this production manufacturing process, and the questions that we ask is, can we classify the quality levels of the engine block correctly when they are produced? That is very early in the process. And the other question is, can we improve the production process by increasing the number of high quality engine blocks? From the data analysis perspective, this was a very challenging problem because it corresponds to a high volume data set, which is highly unbalanced. By this, we mean that basically we need to do an Emory classification problem, and the classes that correspond to different, and the data that correspond to different classes is highly unbalanced. Also, we have very diverse data in the sense that we combine in a single model thermal images and sensor data. So for this problem, we have trained a joint neural network that incorporates both the thermal image and the sensor data, and we have also carried out some undersampling to making the data set more balanced. So what you can see here is the results that we can achieve. So for the 2 models, we have a good accuracy that can be achieved. The second model that takes into account the imbalancedness of the data set overall performs slightly worse, but on the most relevant classes, it actually performs better. And here you can see how the I-BiDaaS architecture can be specialized to the aluminum die casting use case. We incorporate in the solution several of the I-BiDaaS technologies. For example, the Advanced Visualization Toolkit by Aegis, ITML orchestration services, Software AG universal messaging, the trained models by University of Novi Sad, and so forth. And the second and the final use case that I'm going to present is the maintenance and monitoring of production assets. So the context is that different sensors are installed on the production line, and the questions that we want to answer is, can we prevent faults before they happen? And can we see the trend of a sensor's behavior across different days, and also see some similarity between different sensors? From the data analysis perspective, again, we have a high volume data set, and here the data set is unlabeled, which is an additional challenge. From the perspective of analysis, we have applied per sensor outlier detection methods, and we have also provided some means to infer the similar sensors. So what you can see here is the illustration of outliers that can be detected for a specific sensor. We can do this for the historical data, which can be quite useful later in operational processes. Also, what you see here is the histogram of the similarity between different sensors in terms of outliers. While most of them are dissimilar, which you see on the left-hand side, there still is a certain number of sensors that are similar from the perspective of outliers. This is something that you see on the right side of the plot, which is of potential high importance for this use case. Now, final slide is to show how the I-BiDaaS architecture can be specialized to this use case as well. You can see that we again incorporate several tools provided by the I-BiDaaS partners from University of Novi Sad, Software AG, Aegis, CRF, and ITML. Thank you. Now I would like to pass the token to Danilo, who is going to present in more detail the CRF use cases from the domain perspective, and also show a step-by-step demo of the I-BiDaaS solution for these use cases. Thank you.
Thank you, Dušan. Okay. Now, do you see my screen?
Yes, Danilo, we can see your screen.
Okay, thank you, Despina. Now I'll show manufacturing pilot step by step for both use cases that we developed within the project. Before I explain the current situation, data analytics are executed at the moment in factory innovation department, and this is a diagram of the life cycle analytics. We retrieved data from the plant and processed them in our server, where all information are saved and stored. So we can analyze data internally, and we have periodically discussion with manufacturers to understand how to improve the data gathering. With the I-BiDaaS solution, we have identified two production sites. Production sites 1 refers to the aluminum die casting process, and production site 2, in which we made main vehicle. In the first production site, we have a machine with provided with a computer, and we stored where are stored a massive amount of data. Production site 1 refers to the production of a component. In the production site 2, there are several areas provided with sensors, and in this case we have two types of data sets, MES and SCADA, with MES and SCADA data. Data retrieved from the plants are gated in CRF and analyzed. Then we anonymize data and send them to a virtual machine created by I-BiDaaS technologists that send data to I-BiDaaS platform, where there is analytic and visualization tools for the analysis and visualization. Because visualization are very important for us as an end user. Results are sent to the virtual machine and then to CRF. All of these for the privacy of our server. We cannot give access to external. So I-BiDaaS technologists found the solution by utilizing the virtual machine. And in the end, we improve the production processes. In this slide, I reported the CRF data roadmap. We started the project in January of 2018. And in the first part of the project, we identify and defined two use cases. We retrieved data and built a data set, in the first case, as I'll explain then. And going on during the process, we arrived at month 31, in which we are in progress with analytics and visualization. We obtained the result for the first use case and for the second, as I'll show in the demo. The project will end in December of this year. About the production process of aluminum die casting, the first use case, I reported here a schematic diagram of the process. The process is very complex, and we have an enormous amount of heterogeneous data. Molten aluminum is injected in a die cavity, and in output we have an engine block. From die cavity, we have two different data sets. One with die parameters data, and the second with thermal images. And at the end of the process, we have another data set with quality data. CRF merged die parameters data and quality data. So we share with the consortium two data sets. One with parameters and quality data, and the second with thermal data. Our business goal for the first use case is to improve the quality of the process and products, avoiding decrease of quality level, and prevent repairs and reworks, especially, and finally reducing scrap and waste. The goals of the use case is to develop high-level algorithm for the analysis, for the analytics, identify and select critical parameters, and provide us a mode to timely visualize analysis results. This is the data flow for the production process of aluminum die casting. It is the same of the general, and I characterized here the type of data quality parameters and quality thermal data, how we then we collect and anonymize data before sending to the virtual machine for the link to I-BiDaaS platform. Now I show you the demo of our first use case. Do you see?
Yes, Danilo, we can see your screen.
Thank you, Despina. For the aluminum die casting process, we have a diagram in which are reported the most important parameters. Analysis selected the most important because during the process we collected many parameters, near 80, 100. They identify the most important for the classification to quickly understand the situation during the production. If I press on run experiment, I can visualize the trend of parameters and classification level. If I want, I can press on pause start button and visualize a range of values. I can deselect parameters if I want to see only one of them or two or more. And I have another option to see parameter related to the classification level. Then I have also a table, a color table, in which I can see the value of the most important parameters and the corresponding classification level. If I press on timestamp, I can visualize in real time the last that are uploaded. In this chart, I can visualize the percentage of the three classification levels, and other two important charts are these, in which I can visualize the trend of the cylinder block produced and their classification, level 0, level 1, level 2. And in this chart, I can press on timestamp and see the last that are produced. I can choose how many items visualized per page, in this case, and also for the table. It was a great work made by the analysts involved in the project and the technologists for the visualization, because with this solution we can timely, quickly visualize what happened during the process. About the second use case regarding maintenance and monitoring of production assets. In this case, we have data retrieved from sensors, and we are interested in predictive maintenance in order to predict faults before they happen, avoid micro or macro stoppages, and predict unnecessary action. The use case goals in this case is to structure and analyze sensors data with high-level algorithms, obtain thresholds for anomalous measurements, and create a structured foundational database to be easily utilized to track anomalous trend for a continuous and periodic control of service conditions as required from the predictive maintenance. In this slide, I share the situation in the plant. We have over 100 sensors, and in particular, we are interested in accelerometers. The flow is the same of the first use case. Now I'll share with you the demo for the second use case, also in develop mode. In this case, we have a calendar in which we can select year, month, and in this dashboard you can see sensors categorized in this way. We have accelerometer, velocity, temperatures, and etc. If I press on accelerometer, I can visualize all accelerations sensors. We have 87 sensors in this case. And in red, I visualize sensors with anomalies trend, and in blue, sensors without anomalies. If I press on sensors with anomalies, I can visualize anomalies number in for all days, and on any bar is reported the number of anomalies. If I press on bar, I can read the sensor's mean value and visualize the trend of the anomalies. As I said before, this is very important because now data are retrieved with all information, but we think that it should be better to have a database with all sensors anomalies. For these analysts transformed the SCADA data into separate time series, remove duplicate entries for each sensors, and obtained threshold for anomalous measurements. Come back to the presentation. Now I explain you our CRF benefits related to our KPI. we want to reduce costs due to reworks and scrap. So we identify 3 different quality levels. 1 for high good products and 2 related to defective products. Our goal is to increase the first and decrease the second and the third. For the second use case related to the predictive maintenance, the 2 main KPIs are the overall equipment effectiveness and the decrease of cost. So in this case, we want to increase the OEE of 1.5% and decrease maintenance cost of 50%. So we can reduce time to produce decisions from 1 month to real time thanks to I-BiDaaS solution. And the accuracy achieved with new models is better than models used in CRF. This is all for me. I hand over to Despina for the closing sessions. Thank you for attention.
Thank you, Danilo. Thank you, Dušan, for your presentations. I would like now to open the floor for your questions. Use the Q&A panel to post your question, and then we will go through them. I'll raise your hand for to do that live. While you are preparing your questions, I would like to invite Leonardo Longhi from Systematica. He's an electronic engineer, and he's from the Track and Know project, and he's leading the insurance pilot. He's going to say a few things about the next webinar of the series. Leonardo, the floor is yours.
Yes, thank you, Despina. And first of all, to everyone, I'm going to tell you what we're going to talk about tomorrow. Can I have this? Okay, thank you. Okay, I'm Leonardo Longhi and work for Systematica, that is a partner of the Track and Know project. It's on Horizon 2020. The project is now in the last quarter, and we are achieving a lot of goals, a lot of KPIs that's in insurance sector, in electric vehicle mobility, in smart telematic insurance. And my role in Systematica is as a software developer and a project manager, let's say. And I work as a consultant both for the insurance sector and the electric vehicle sector for one of the two, one of the main players in insurance, and another one, car manufacturer in Italy. And next slide, please. Okay, our pilot is composed by 3 main business cases. 3 business cases, as said, is insurance, electric vehicle, and car sharing. We produced 3 concepts of 3 products that we would like to use that to estimate the risk in insurance and decrease the risk on the road, and use this feature in order to address also feedbacks in car sharing websites and car sharing social networks. And this is for the first product, that is the driver coach. The second product is use it in 2 main areas. One is the car sharing, and the other one is electric vehicle mobility. We find we put some information about the user. We track the user by the IoT system provided by the insurance companies, and with that data we are able to infer habits and to produce a schedule of which trips can be shared as a passenger or as a driver, and which other with other trips can be substituted as electric vehicle mobility paradigm. So basically, we will propose something that can produce a leverage for clients in order to shift from an internal combustion engine car to an electric vehicle car. And on the other hand, we are able also to provide to the car manufacturer an estimation of the actual market. This is what we are going to do and finish, and we're going to talk tomorrow about. If you have any question, you are very welcome, and I'm very happy to reply to you, to answer to you.
Okay, thank you, Leonardo, for
You're welcome.
The introduction to the next webinar. Don't miss this. It is this Tuesday. Apologies. So before we go to the questions, in the chat box you will find a link. We have created a questionnaire. Your feedback is valuable for us. So it will take only 2 or 3 minutes. So please go ahead. So we do have 2 questions from George Agarakis. The first one: how fast is the anomaly detection to be used with streaming data? Dušan or Danilo, would you like to answer this question? Dušan, we cannot hear you. Dušan? Danilo, the second one is: how do we specify exactly the KPIs? Why 6% and 7% or 8%?
Okay.
Maybe Danilo, you can reply this one, and then we will go back to the previous one.
About the second questions, we put our goal with a value, but if we increase the quality level of good piece of a range, we have a range of percentage that are good for us and not a specific value. Surely, if we can reach 7 or 8 is better, but I indicate a range from one value to another that will be better for us in order to decrease reworks and other operations.
Thank you, Danilo. So one question
left.
Can
you hear me? Can you hear me now?
Yes.
Okay. Sorry, there seemed to be some problem with the headset.
Yep.
Okay, so the question is: how fast is the anomaly detection to be used with streaming data? Actually, for the requirements for this use case, I think that we were mostly interested for the batch analysis, for the historical analysis of anomalies. On the other hand, the methods that we used are not computationally very intensive. So, for example, the methods of type IQR test for outlier detection, and also the methods are up to now decoupled across sensors. So I believe that they could be feasible to be used also in streaming like process. So using this kind of methods or some other not expensive, computationally not expensive outlier detection methods would definitely be possible to use. Thank you.
Despina, we don't hear you.
now.
Yes.
The technical problems today are continuing. Okay, so thank you, Dušan, for the reply. I do have one more question for Danilo. Danilo, can you share with the audience the CRF story regarding data sharing and data availability? Where you were at the beginning of the project, where are you now, what you have managed to achieve? Any lessons learned for the audience today? And now, Danilo, you are muted.
Yes, yes. Thank you, Despina, for this question. It's a good question because we are working with data. When the project started, we retrieved data from different sources and different levels. We analyzed all information that we received from the plants. We at the beginning we have small data to use for the big data, to test the big data technologies. So we decided to use synthetic data to have a flexible and rich data set to share with the consortium and to test the pattern and the I-BiDaaS technologies. In second part of the project, we received more data and we guaranteed our suppliers the anonymization of data. So we shared real anonymized data with the consortium in order to test the complexity of the process with the technologies developed by analysts and technologists that are working in the I-BiDaaS project.
Thank you, Danilo.
You're welcome, Dustin.
Okay, so I don't see any other questions. I think we can now conclude. I would like to thank you, Dušan and Danilo, for your great presentations. I would like to thank you all for being here. Actually, this is the final webinar for I-BiDaaS. There are two more for the Track and Know project. I would like to thank you all for your feedback, for being here. Don't forget, the webinars are available in our YouTube channels. So, on behalf of the I-BiDaaS Consortium, thank you all. Thank you all for being here with us. Have a nice afternoon and take care.
Thank you.
Thank you. Thank you.
Bye.
Bye.
Thank you.